Okay, question 9. I think this is getting into real proper higher now. Okay, this is bigger question, bit more involved than some of the other ones, so slightly trickier question. So the x-coordinates of the stationary points on a graph. So we've got our polynomial. What are the x-coordinates of the stationary points? Okay, so again, like I said, if you're thinking stationary points, you should be thinking differentiation. So it's going to be x cubed plus 3x squared, take away 24x. And when I'm doing this, I will just start off, just to remind me what I'm doing. If I differentiate x squared, I'm going to get 2x, because I multiply these terms and take away 1. Okay, just to remind me. So dy by dx will be 3x squared plus 6x, take away 24. Right. So that's the equation that's going to tell me what the gradient is at any point along this polynomial. And to find the stationary points, well, dy by dx is going to be equal to 0 at a stationary point, because if I've got a polynomial, something like this, as we see, we've got a negative gradient, a positive gradient, a negative gradient, so negative, 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 but at the turning point, before we get to these negative and positives, the gradient would just be 0. See here, terrible. See here, if we were drawing a tangent to that point, we'd have a negative gradient, tangent on there, positive. Again here, we've got our 0. Okay. So just have a wee note there, just to say, yep, I know what I'm doing. I'm looking for when it's 0, my 0 gradient at the stationary point. So 0 is 3x squared. And like many of the answers in higher, the answer to this one is also factorise. This is quite a good one. I can take out 3. So then that's x squared plus 2x take away 8. And I'm looking for numbers that add to this and multiply to this. So I'm thinking 4 and negative 2. So x plus 4, x negative 2, which means that my roots of my equation are x is negative 4, x is 2. And by roots, what I mean is the solution to when dy by dx is equal to 0. So yeah, the x-coordinates are 2 and negative 4. So just to go through the marking scheme for that one, you would get a mark to start to differentiate, and you would get a mark to finish it. So let's say you would start getting a mark by doing this. Very nice. And you would finish that mark, another mark for here, finish it and put it equal to 0. Then you would get your mark factorising and your final answer. Okay. So again, not bad. Known to start to differentiate, you get a mark. Okay. The next question is saying, we'll determine the range of values for which this function is increasing. Strictly increasing. All that means is it's got a positive gradient. Okay, strictly increasing, we've got a positive gradient. So what would really help is if I knew what it looked like. If I knew what this original function was, this one up here, it's so easy. Say it did something like this. Like, well, it's increasing here, brilliant. But I don't know what the original function is. All I know is what the differential's like. Work that out as well. All I know is what the differential's like. So for B, I'm going to say, okay, there's my wobbly y-axis. And I know the roots of my differential are negative 4 and positive 2. And I also know that it's a positive x squared. So it's doing something like, this is really hard to draw on this, I don't know why I'm so bad at it, but that's not too bad. I know it's going to look something like that. Now this is where x is on the horizontal and dy by dx on the vertical. So what that's saying is anything above the x-axis, that's a positive gradient, yeah? Because if I was to go along from, say, here to here, if I was to go along from here to here, I would get a positive, that's the gradient of 1, gradient of 2, gradient of 3, etc, etc, etc. So anything above that x-axis is positive. Anything below that x-axis is negative. So quite simply, when x is less than negative 4, it's increasing, and when x is greater than 2, it's increasing. That's my positive gradient. If I wanted to know when it's decreasing, it would be decreasing, so I'll say increasing. It would be decreasing between 2 and negative 4. That's when it's decreasing. Where is it 0? Well, the gradient there is 0. The stationary points are 2 and -4. So if I was trying to draw this out, it might look something, let's have a think. I've got a positive gradient, so this is going to be up to here. Let's see, it'll be positive up there. So it has to be a positive gradient here. Between here and here has to be a negative gradient between these 2 points, and then it has to be positive. So maybe it's doing something like this. Maybe it's going positive. And don't forget, on these points, we have to have a stationary point as well. So maybe it's a positive gradient, and then we've got a turning point, so that's a negative, so that's negative gradient, and then stationary point, and then back to positive again. It could be that. I'm not quite sure because I don't know the nature of these turning points. Not sure. If you wanted to work that out, FYI, and this is how you can also solve this question, you could differentiate again. Okay, so I'm just going to rub out decreasing. Oops. Or I'm going to highlight it. Yeah, so a wee bit longer this video, just thought I'd chat about some of these because there's a few really interesting points come up. So if I said that for B, instead of doing this way, which I like, just drawing your graph and saying x plus, you could have said, okay, I know dy by dx is equal to 3x squared plus 6x take away 24. You could differentiate that again, d2y by dx squared, and just the exact same as before, so 6x plus 6. And now what we do is substitute our value of x in, and it will tell us the nature. And what happens is, if this is greater than 0, it means I've got a minimum turning point. If it's less than 0, I have got a maximum turning point. And if it's equal to 0, I've got a point of inflection, and I'd have to go and do a nature table. So let's see what we would get if I put in -4 into this. 6 times -4, -24. It's going to go with a negative number, isn't it? So that looks like it's going to be a maximum turning point, just like this one. If I put in x is 2, 12 plus that would be a positive, yeah? So that is going to be a minimum turning point. So if you could do it that way as well if you wanted. You could try and draw out the whole thing. But yeah, I just thought I'd show you that as a little extra. But anyway, for this one, you would get your 2 marks for, let's have a look. Method 1, yep. Know how to identify where the curve is increasing. That's all it actually says, so that's fun. Yeah, doesn't actually seem to point out where the marks are. It looks as if it's more a mythology thing where you're drawing your graph out. So I'm just going to do tick and tick. But yeah, it looks as if you get your 2 marks for knowing your process. So if you got the wrong answer, you'd lose a mark. But by knowing how to kind of draw it with the roots, you would get a mark for that. So yes, I hope that is helpful.